In Creo Parametric, you can use Program to turn your model's regeneration cycle into an interactive process. In previous videos, I've used Program to ask the end user a series of prompts, and then based on the inputs, have different components have different dimensional values. Also, in an earlier video, we used a yes/no prompt in order to select different instances of a family table. I've added a couple more family tables to this assembly. For example, here we have a bolt. Let me right mouse click and choose to open the generic. And then I'll choose open the generic again. If I go to the model intent overflow menu, I can go to family table and show you that I have a number of different bolt instances that I created in another video. And the family table has two different dimensions: the shaft diameter and also the length of the bolt. Let's cancel out of here and go back to the program assembly. Similarly, I have a nut with a family table. Once again, I will right mouse click and choose open generic and open the generic once again. Go to the model intent overflow menu and then click family table. And here we have a bunch of different nuts where they have different diameters and they have heights. And really what I want is the diameter to be selected from this one. So once again, let's cancel out of here, go back to the assembly, and start writing our program. Let's go to the model intent overflow menu and then choose program. From the menu manager, I'm going to choose to edit design. And let's go over to the inputs, and I'm going to create a new input variable, and I'm going to call it hole diameter. And I just like doing everything in all capitals. This is going to be of the type number, and then I'll write my prompt in here. So that is good for the input. Next up, I want to have this hole diameter change the values of different dimensions in the model. I happen to know the different dimension names, so I could write them in here, but I'm going to exit out for a moment. Oh, I do want to save. Yes, I want to incorporate my changes. And let's choose to enter in the different values. Let me select all just to show you how everything's working. This is the new variable, but nothing is being driven by it yet. So I will choose done select and ask me for the diameter on the inlet side. Let's use 36. Number of bolts there, let's choose 8. Diameter on the outlet side, let's use 18. Number of the bolts on the outlet, let's choose 4. The hole diameter right now has a value of 0. Let's enter in a value of 1. I happen to know that the hole diameter right now is a value of 2, but I'm going to use a value of 1. Since I have program in a subassembly, I'm going to enter in values as well. And let's select both of them and done select. And the height right now is 40. Let's change that to 20. And do I want a straight pipe? I'm going to choose yes. And so the model updates accordingly. And now let's say I wanted to have the different diameters of components driven by that relation. I'll show you how to do it manually using the standard relations dialog box. Let me select this component to begin with, and I will choose to isolate or show only this particular component. There you can see the different holes in here. I will go to the relations dialog box, and let's start off with a comment line, / and an asterisk. And I'm going to control the hole diameter in components by input variable. If you take a look in the list of local parameters, here's that hole diameter in there. I will select the hole in here, and you can see that we have a bunch of different dimensions, and it's showing you the names of the different dimensions. This is the dimension in the component that controls the hole diameter, so I'll click on it. And I accidentally forgot to click on a separate line. Let me go to a blank line, and that dimension is D8:0. D8 is the name of the dimension in the plate, but the :0 is the component ID number. So all these different components in the assembly are assigned an ID number, and that's how the program knows that, hey, we want to use the D8 dimension from the plate part as opposed to the D8 dimension from another component. And I'm going to make that equal to, and I can type in hole diameter manually, or I could use this button over here to insert the parameter, just to make sure I don't mistype anything. Then we can verify everything's good, and I click OK. Then when I regenerate, and I'll just use current values for everything, you'll notice that the holes end up getting smaller because now that's being driven by a relation. Similarly, I can go back to the other different components and choose, let's see, let me just get everything back. I could do the same thing for changing the diameters of the holes in the reducer and also in the pipe part, or I could do it in program. Let's go to the Model Intent Overflow menu and go back to Program, and I'm going to Edit Design. And you can see, hey, here we have that relation in the program now. Let's go and create some other different ones in here. And this is a slightly different method than the method I used in the first Pro Program video. In the first Pro Program video, I used the execute statements in order to pass a bunch of these different inputs down to different components. So for example, if I scroll down over here, let's find a component. So here's the plate program, and we're assigning the D7 and P13 dimensions to be values of different inputs. Alternatively, you could write relations at the assembly level. And in other videos, I've talked about the reason why you might not want to use assembly level relations, mainly because they are effective only when you have the assembly in session. But for simplicity in this video, I am going to write the relations here. And so, for example, the reducer is component ID 2, and it's got a couple different dimensions, D6 and D33 for the hole diameter. Let's type that in. And the other one for the reducer, I happen to know that that dimension is D33:2. That is going to be equal to hole diameter as well. And let's see, the one in the pipe, that's going to be the D4 dimension, and its component ID number is 6. That's going to be equal to hole diameter as well. So that's another way of writing relations. You can write them here in Pro Program. Let's save and then exit. Yes, let's incorporate our changes. Now I'll choose current values and current values. And I'm just going to do that and like hide this component over here, just so that when we hit done return out of there, let's see, if I go to analysis, measure diameter, actually that one looks a little big. That one right now has a value of 2. Let's go back and regenerate, and I'll do current values and current values. Let's see, if I go to relations, pick this dimension over here. Okay, now we have the D18 dimension. Let me make sure that that one is correct. When I swapped out, it ended up getting a different component ID number. So now let's click the OK button. Regenerate, current values, current values. There it goes. There, now the hole gets smaller. But we're still using the same size bolt. So we've got to then say, hey, we want to look up which bolt that should be used in these different cases. So let's take a look at first the top level. We have these top level different bolts inside of here. Let's now go back to the program, and we're going to write in a couple other different relations to use a lookup function. I'll go to Program, Edit Design, and now over here, let's do a comment line, look up correct family table instance. And so now we're going to create a new parameter that's going to have some name, and then we're going to use the lookup function. So for example, for the name of the bolt, I'm going to call that bolt name. That's going to be equal to, and then we'll use our lookup underscore inst, lookup instance function. And the first argument that you're going to pass to it is the name of the family table generic. In this case, it's bolt.prt. Then the next argument that you're going to pass to the function is going to be the match mode. If you use a value of 0, then you're going to look for instances with the exact value. If you use a value of -1 for the match mode, then you're going to look for an instance with the same value or lower or less than. If you use a match mode of 1, you're going to look for the same value or greater. In this case, let's say that someone enters in some weird oddball number for the bolt diameter. I want to go to the next greater instance. So instead of using a match mode of 0, I'll use a match mode of 1. That should make it a little more robust working in here. The next argument that you're going to pass is the first value you want to look up, the first family table column that you want to compare against. And I happen to know in the bolt part, the name of the diameter shaft underscore DIA. And I want to compare that against my input, which is hole underscore DIA. That's this value over here. And I automatically want to grab the bolt that has a length of 4. So again, I'll put in the name of the family table column and then the value that I want it to have, and that's good. Next up, let's do the same thing for the name of the nut that we want. And again, it'll be the lookup inst function and the name of the generic in quotations. The match mode, again, I'm going to use a match mode of 1. And the only one that I want to compare against is the family table column called diameter. And I want that to match the hole diameter. So that is good for my 2 lookup instance functions. At this point, I'm not going to do anything. I'm just going to calculate the variables to show you what ends up getting put in there. So let's choose save out of here and then exit. Yes, I want to incorporate the changes. Right now, if I bring up my parameters dialog box, you don't see the ones in here, but let's go regenerate, and I'll just use current values again. Now when I go to the parameters dialog box, oops, let's just go back to the program. Let's see, I needed to regenerate. Let's do from file. Okay, there we have it in here. Let's save and then exit. Yes, we want to incorporate the changes. Yes, we want to execute. And let me just choose to enter in the hole diameter. Done, select. And this time I'll use a value of 1.5. And I'll just use the current values for the subassembly. Oops. And now when I go to my parameters, you'll notice that here we have the bolt name is being calculated. Looks like it didn't create the nut name one. Let's go back into the program and edit the design. Oh, here we go. Have an extraneous period in the name there. So let's make that change and then save and then exit. Yes, I want to incorporate the changes, and let's again enter in for a hole diameter. This time I'll use a value of 1, and let's just use the current values for the subassembly and then done return. Now when I go to the parameters, here we have it's looking up the correct instances from the family table. All right. That is good. Now we have to tell the software that we want it to use the family table instances. Let's go to the program again, edit design, and now I'm going to scroll down and find where we are putting in those components at the top level. So here's the name of the instance that it is currently using. We're going to get rid of this for the first one, and then in parentheses we're going to put in the name of that variable, bolt name. That is good. And the other ones, it'll update once the pattern is generated. Let's go to where we have the first nut called out, and for the add part line, we're going to replace that with the name of the variable that we created. So that is good. Let's hit the save button, and then let's exit. Yes, we want to incorporate. Let's use current values and current values. And now you'll notice that we got much smaller fasteners in here. They are updating appropriately. Let's then try making another change. I'll just hit done, return out of there. Let's regenerate, and let's enter in different values. And I'm just going to change the hole diameter and then hit done select. Now let's use a bigger diameter of 2.5. And I'll just use the current values in the subassembly. And now you'll notice that we got bigger bolts and nuts in the top level of the assembly. Let me just look at this one individual part here and confirm the diameter. Analysis, measure diameter, and pick one of these holes over here. There it is, indeed a value of 2.5 like I just entered. All right, let's take a look at the subassembly. Let's show it as well. Oh, did I get the wrong one? Let's choose to see everything. So now what I want to do is I want to make sure that the components in the subassembly are changing appropriately as well. So in order to do that, I need to pass those values for the bolt name and the nut name down to the subassembly. And to prepare for that, I am going to, there we go. Just did a little control A. I wasn't getting the open command from the mini toolbar. Here I am in the subassembly, and I'm going to go to the program, edit the design, and we're going to add in a couple of other additional inputs. We want it to receive the bolt name and the nut name from the higher level, and let me specify that these are string variables. That is good. Let's save out of here and then exit. Yes, we want to incorporate, and I'm just going to hit current values in here because, again, all I've done is I've said that this is supposed to receive those different parameters. I haven't sent them from the higher level assembly yet. So back over here, let's now go to the program and edit the design, and let's go down to where we execute the subassembly. And again, in a previous video, I sent 4 different variables from the top level assembly down into the subassembly. Let's repeat the same process for bolt name. That's going to be equal to bolt name and nut name. All right, let's save out of here, and then we're going to exit. Yes, we're going to incorporate the changes, and I'll just do current values and current values again. Now when I hop back over to the subassembly and open it in its own separate window, now if I go to the parameters, you'll see that it's received the 2 parameters from the higher level assembly. Let's now go to the program and tell the subassembly that it should use those particular instances. So let's go to program, edit design, and scroll down to where the pattern of fasteners are added. And just like the way that we add the pipe by a variable, we're going to do the same thing for these different patterns. So we're going to take out the name of the instance that's called up in here, and let's change that to, let's see, this is going to be equal to bolt underscore name in parentheses. And let's scroll down to the pattern of nuts. We're going to do the same thing. We're going to take out the name of the first instance over here and put in the name of our variable in parentheses. That's good. Let's save out of here and then exit. Yes, we want to incorporate the changes, and you'll use current values. You might have noticed that the bolt got slightly bigger. So now the program is running correctly at the lower level. Let's go back to the top level and try changing a whole bunch of different things. Let me make sure that everything is visible. View, unhide all. Okay, so there we have all the different components, and go to the model tab. Let's hit regenerate, and I'm going to enter in. Let's enter in everything. Select all, done select, and let's see the diameter on the inlet side. Let's make it small. Let's make it a value of 20. And the number of bolts on that side, let's use a high number of bolts, 12 over there. Diameter on the outlet side, let's use a value of 10. Number of bolts on the outlet side, let's use a value of 8. And the hole diameter, right now it's using a value of 2.5. Let's change it to that lower value of 1. Now for the lower level, let's enter in, let's change the height. And for the height of the reducer, let's change this to a value of, let's make it bigger, 30. And so there you see that it changed the size of the bolts and the nuts. And although you can't see them, it also changed the size of the holes in the different components. Let's do one more regeneration. And this time I'm only going to change the bolt diameter. Let's change the hole diameter to a value of 3, and just use the current values for the subassembly. Whoa, those are way too big. So there you can see how we are using the Lookup Inst function in order to programmatically replace different instances of a family table. I hope you enjoyed this video. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.